Hi, in this video we're going to talk about the geometric series formula. How do we derive it? And this is useful in finance because it is another way of saying what is the sum of cash flows. So if you have a recurring payment of some amount of money that you're getting over the year, say $100 a month, and you have so many years, well, how much money are you going to be getting out of the whole thing? So this is going to be extremely useful when we're calculating annuities in future videos, but we should start with the basics, and here's how we're going to do that. A is our first term, our first cash flow. R is our common ratio, which is our interest rate. N is the number of terms, and Sn is the sum of the first n terms. This is for a finite geometric series, by the way, so you actually know when the amount of cash flow stops. Okay, so let's begin. We start off with Sn is equal to our first cash flow payment plus our second cash flow payment times our discount rate plus our third cash flow payment times our discount rate. And this is just going to continue on all the way until we get to a times r to the n minus 1. You might be tempted to put a times r to the n, but you have to remember that really this is not a times this is actually a times r to the exponent of 0. This is a times r to the exponent of 1. So we're actually always one term behind. So that's why when we get to the end, it's going to be a times r to the n minus 1. So if you were to just stop here and calculate this by hand, you'd have your first cash flow, $100, $100 times discount rate, $100 times discount rate, all the way for however many years and however many payments, and you just add them up and get S of n. Now that could be a pain in the butt, and if you don't have a spreadsheet or some kind of fancy calculator, you might not want to do this by hand. So let's figure out a little math trick, and what it is you can times both sides by a times negative r, or negative common ratio, and that's going to give you negative a to the r minus ar squared. And this is going to continue, and we're going to go one term before this, and that's going to give us a times r to the n minus 1. And then finally we're going to have negative a times r to the n, because r to the n minus 1, if you times that by r, that gives you a times r to the n. So now that we've done that, what can we do with this information? Well, we can see there's some common terms here. We can cancel some of these out, and that's interesting. So what happens if we simplify this? Now what do we have? Well, we have S of n minus r s of n equals to a minus a times r to the n, and we can simplify that even further. So that's going to give us 1 minus r, and that's equal to a, which is 1 minus r to the n. We can bring everything over to one side, isolate for s of n. That's going to give us 1 minus r to the n over 1 minus r. Whoa, okay, so this looks familiar. Well, if you're in finance, you've seen this before. This is our sum of cash flows formula. So this is another easier way of writing out all of this, and you only have to do it in one step because you know all the variables that you need. You have the number of terms, you have your discount rate, you have your amount of money you're getting paid for the cash flow. So this is our geometric series formula. This is how we've derived it, and it's extremely useful when we're calculating annuities, and we'll use this in future videos. But if you're here for the math reasons, this is a finite geometric series, and here's the formula that you can use. So hopefully it's helpful. See you next time.